Above our heads stretches a colossal galaxy, and yet we barely know its secrets. The Milky Way is not just the home of our planet, it is a vast ocean of stars, invisible worlds, and mysteries that we have yet to fully understand. In this journey, we will discover 20 astonishing facts about our galaxy, data that will change the way you look at the sky and reveal how much we still have to learn about our own corner of the cosmos. The Milky Way is a cosmic landscape filled with extraordinary phenomena, from the surprising existence of star streams that seem to tell the story of devoured galaxies to mysterious structures of dark matter looming above us. Every corner of our galaxy hides something fascinating. Have you ever wondered why there are regions in space where there should be stars but seem to have completely disappeared? Imagine for a moment the energy bubbles emerging from the center of the Milky Way. Colossal structures of unknown origin that challenge our understanding of the cosmos. What generates them? Are they signals of something greater? As we explore, we discover that the Milky Way is not a flat place. Its shape is wavy, and its thickness is an enigma in itself. Why do these deformations appear in its structure? And let's not forget about hypervelocity stars, those celestial bodies moving at such impressive speeds that they seem to be escaping the galaxy. What propels them to such velocity? Additionally, there are exoplanets that wander alone in the darkness of space, far from any star to give them light. How is it possible for these worlds to exist in the solitude of the cosmos? Each of these mysteries leads us to delve deeper into the history of the Milky Way, a history intertwined with that of other galaxies, such as the Magellanic Clouds, which seem to nourish our own galaxy with interstellar gas. But what lies behind this cosmic exchange? Cannibal stars, which absorb others into themselves, also raise unsettling questions about the nature of stellar life. As we venture into the heart of the Milky Way, we find a black hole that governs everything around it, Sagittarius A*. But what does it really mean to have a dark giant at the center of our galaxy? And as if that weren't enough, the future of the Milky Way is equally intriguing. The collision with the Andromeda Galaxy is an inevitable event, but how will that monumental encounter unfold? As we unravel these mysteries, it becomes clear that the Milky Way is a field of endless exploration. The search for dark matter, the composition of most of the galactic mass that escapes our view, remains one of the great challenges of science. Each question leads to new inquiries, and each answer brings us a little closer to understanding our place in the vast universe. So as we embark on this fascinating journey through the Milky Way, prepare to discover not only the mysteries that surround us, but also the wonder of continuing to explore a cosmos full of surprises. Are you ready to delve into the secrets of our galaxy? Have you ever wondered how the Milky Way feeds on other galaxies? One of the most fascinating mysteries of our galaxy is the Antlia stellar stream, a current of stars that suggests the existence of a galaxy that was once devoured by the Milky Way. But what does this really mean? Imagine a galactic banquet where our Milky Way is satisfied by consuming other galaxies. In that process, it leaves a trace, and that trace is precisely what we observe in the Antlia stream. This stream is not just a group of wandering stars. It is a trail that extends over thousands of light years, formed by stars that share a common history. But what caused these stars to separate from their original home? The answer may lie in the gravitational forces of the Milky Way, which, like a cosmic predator, attracted these stars toward its core. This leads us to wonder, how many galaxies have been consumed by the Milky Way throughout its existence? The Antlia stellar stream is located in a region of the sky that at first glance may seem empty. However, when observed with powerful telescopes, astronomers have been able to detect this flow of stars that, together, form a coherent structure. But why is this discovery important? The answer lies in the fact that studying these streams helps us understand not only the history of our galaxy, but also the dynamics of galaxy formation in the universe. What other secrets might the Antlia stellar stream reveal? Some scientists believe that these stars may hold clues about the composition of their parent galaxy and consequently about the environment in which they formed. This opens the door to a series of intriguing questions. What type of stars were they? What was the galaxy from which they were expelled like? And what does this tell us about the evolutionary history of the Milky Way? Moreover, this phenomenon may be related to dark matter, an invisible component that surrounds the galaxy and, although we cannot see it, has a significant impact on its shape and behavior. How does dark matter influence the Antlia stellar stream? The interaction between visible and dark matter is an active field of study that could unveil many of the galactic mysteries that remain to be solved. As astronomers continue their research, another question arises. Could there be other similar stellar streams in the Milky Way? The answer seems to be a resounding yes. In fact, several stellar streams have been identified, each with its own story. This suggests that the Milky Way has been in a constant process of galactic cannibalism, accumulating stars and gas from other galaxies throughout its life. Thinking of the Milky Way as a living being that feeds on other celestial bodies is fascinating, but what does this imply for our place in the cosmos? If our galaxy is the result of countless encounters and assimilations, then what does this tell us about our future? The Milky Way is not just a collection of stars, it is a dynamic entity, always in motion, always changing, and that includes the solar systems that inhabit it. Of course, the Antlia stellar stream is not the only mystery surrounding us. This phenomenon invites us to reflect on how galaxies interact with each other in the vast ocean of the universe. Could it be that in a distant future, our own galaxy becomes the mother of new stars that will form from other galactic systems surrounding it? This idea is not only captivating, but also reminds us of the cyclical nature of the cosmos. As we explore the Antlia stellar stream, it is essential to highlight that science is in constant evolution. Each new discovery leads us to rethink what we know about the Milky Way and its surroundings. Human curiosity, that innate drive to discover the unknown, remains the driving force behind the study of the universe. Every question we pose opens the door to new investigations and the possibility of unveiling the enigmas that still remain in the darkness of space. Finally, what can we learn from the history of Antlia and the galaxies devoured by the Milky Way? It reminds us that the universe is full of stories waiting to be told. The Milky Way, with its flow of stars, is just one of the many narratives that make up the vast tapestry of the cosmos. As we continue to explore, it is crucial to keep that spark of curiosity alive. After all, every mystery solved is one step closer to understanding our place in the universe. If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this Star Odyssey. The Milky Way, our home in the vast universe, is a place full of mysteries, and one of them is its dark halo. But what exactly is the dark halo? Imagine an immense bubble surrounding our galaxy, composed of something we cannot see or touch. This structure is so large that it extends far beyond the stars and dust we can observe. So why is this dark halo so important? This halo is not made of ordinary matter, but of dark matter, a form of matter that does not emit light or any other form of electromagnetic radiation. This means we cannot detect it directly with our telescopes. But how do we know it exists? The answer lies in the way stars and galaxies move. The laws of gravitation tell us that the speed at which stars orbit the center of the Milky Way should depend on the amount of mass in the galaxy. However, we observe that stars in the outer parts rotate at much higher speeds than we would expect. What is causing this anomaly? The answer seems to lie in the dark halo. This halo acts like an invisible cloak surrounding our galaxy, increasing its total mass. It is estimated that dark matter accounts for about 95% of the total mass of the Milky Way. This raises an intriguing question. What is dark matter? Despite decades of research, it remains one of the greatest enigmas in astrophysics. Some scientists suggest it could be composed of exotic particles that we have never observed, while others believe they could be primordial black holes. Dark matter also plays a crucial role in the formation of structures in the universe. Without its gravitational influence, galaxies like ours could not have formed. But how is this dark matter distributed in the halo? Theoretical models suggest it forms a kind of cloud that extends far beyond the visible stars in our galaxy. However, the exact shape and density of this halo remain a mystery, as if that weren't enough. The dark halo of the Milky Way is not alone. Other galaxies also seem to be surrounded by similar halos. This suggests that dark matter could be a fundamental component of the universe, but why can't we detect it? We have yet to find a way to interact with it directly. This leads to a fascinating question. If dark matter is so abundant, why don't we see it? Perhaps it's because it does not interact with light. Or maybe because it is composed of particles that do not respond to electromagnetic forces in the same way as normal matter. Over the years, scientists have devised different experiments to try to detect dark matter. Some have built underground laboratories in search of these elusive particles. Others have launched telescopes into space in the hope of capturing radiation that could indicate its presence. However, so far, all these efforts have resulted in more questions than answers. Are we really close to understanding what dark matter is? Or have we wandered into a labyrinth of theories and hypotheses? The dark halo also has implications for the future of the Milky Way. As we explore further, we wonder how this matter influences the evolution of our galaxy. Could it be affecting the formation of new stars? There are theories suggesting that the dark halo might be feeding the gas that forms new stars. Although this is not yet confirmed, moreover, the dark halo is not a static phenomenon. Some research suggests it may be changing over time, perhaps due to interactions with other galaxies or the movement of dark matter within it. This leads us to ponder how the Milky Way itself will be affected in millions of years. Could the dark halo be the key to understanding the ultimate fate of our galaxy? Ultimately, the existence of the dark halo reminds us that there is much more in the universe than we can see. There exists a vast realm of matter that, although invisible, profoundly influences the structure of the cosmos. The quest to understand this dark halo is not just a matter of scientific curiosity. It is a journey to the very heart of how our galaxy works and, by extension, the entire universe. So, as we look up at the starry sky, it is important to remember that there is a hidden world surrounding us, a world that challenges our perceptions and expands our boundaries of knowledge. The Milky Way, in its essence, is a place of wonders and mysteries, and the dark halo is just one of the many pieces of this cosmic puzzle that we are still trying to solve. What happens in the vast expanses of the Milky Way where the brightness of the stars seems to fade away? There are mysterious regions known as voids that challenge our understanding of the cosmos. These areas have intrigued astronomers and scientists for decades, and today we will explore some of the secrets they hold. Imagine a place where we should see stars, but instead we find only a dark void. Why do these zones exist? One of the most fascinating theories suggests that they could be the result of the gravity of other galactic structures that have attracted light, creating a black hole effect in space. But what structures could be massive enough to influence the distribution of stars in that way? Moreover, some believe that these empty regions could be related to dark matter, that mysterious substance that makes up most of the universe but remains hidden from our eyes. Could it be that these voids are, in fact, an indication that dark matter is acting in ways we do not yet understand? Dark matter does not emit light, which could explain why some areas of the sky appear stripped of stars. Another question that arises is, how do we know that these voids are, in fact, empty? In such a vast universe, astronomers use state-of-the-art telescopes that can detect the light from distant stars. However, when observing these areas, they notice a remarkable lack of stars compared to other parts of the galaxy. This discovery has led the scientific community to question what we know about star formation. The existence of these voids also raises questions about the history of our galaxy. Could they be the result of past interactions with other galaxies? Perhaps at some point in history, the Milky Way absorbed a smaller galaxy, leaving empty spaces where there was once a bustle of stars. Such galactic events are not uncommon, and studying these voids could reveal more about the evolution of the Milky Way. But what about the stars that are present in other parts of the galaxy? These stars, which shine brightly, may be surrounded by clouds of gas and dust that are not visible in the voids. It could be that the light from these clouds is obscuring the brightness of the stars, creating the illusion of emptiness. Nevertheless, astronomers continue to seek ways to explore these clouds to unravel their secrets. And then we encounter another intriguing question. Is there other forms of life in these voids? The absence of stars does not necessarily mean the absence of matter. There could be other types of astronomical objects, such as rogue planets or black holes, that we have yet to detect. The possibility of unexplored worlds in these shadowed areas adds a touch of mystery to our search. The study of voids also offers us a window into the future. As we advance in technology and improve our observational capabilities, we might discover that these areas have more to offer than we think. What surprises await us in our journey through the Milky Way? The answers could be closer than we imagine. As scientists continue to investigate, new theories arise. Some suggest that the voids could be the result of a phenomenon known as universal expansion. As space expands, galaxies move away from each other, creating voids in the cosmic fabric. Could these empty regions be a manifestation of that phenomenon in our own galaxy? Exploring these regions also leads us to reflect on the nature of the universe as a whole. What other mysteries lie hidden in the shadows of the Milky Way? Each discovery brings us closer to a deeper understanding of our place in the cosmos, and the voids are just a part of that story. On this journey through the Milky Way, it is important to remember that every question we ask opens the door to new investigations and discoveries. The voids are a reminder that, while there is much we have learned, there is still a vast ocean of knowledge to explore. What else will the universe reveal as we delve into the mysteries of our galaxy? Ultimately, the quest for answers about these voids is not only a scientific endeavor, but also a human journey. It reminds us that, as curious beings, we are always seeking to understand our surroundings. The voids are an enigma, but they are also an invitation to keep exploring, to keep questioning, and above all, to marvel at the immensity of the cosmos that surrounds us. Have you ever stopped to think about the enormous energy bubbles that emerge from the center of our galaxy? These fascinating structures, known as the Fermi bubbles, are a true enigma for astronomers. But what exactly are they, and where do they come from? Join me in unraveling this mystery. The Fermi bubbles extend thousands of light years and are the result of intense energy activity. Their name comes from the Fermi Space Telescope, which detected the gamma radiation emanating from them. But what generates this energy? Some scientists believe it could be related to supernova explosions or the activity of the supermassive black hole at the heart of the Milky Way. However, there is still no consensus on their origin. Imagine a titanic explosion in space. When a massive star reaches the end of its life, it can explode in a supernova, releasing enormous amounts of energy. This phenomenon could have left traces in the form of bubbles of hot gas. But are the Fermi bubbles the result of one or several supernovae, or is there something more at play? The answer is not simple. Some researchers suggest that these bubbles could be the result of a jet of particles emanating from the central black hole, known as Sagittarius A*. This black hole, with its immense gravity, could be ejecting material at incredible speeds. But why do two bubbles form instead of just one? Is it possible that both are connected in some way? The theories are many, but the mysteries persist. The Fermi bubbles are not only interesting for their shape and size, but also for their composition. They are filled with highly energetic electrons that emit gamma radiation. But what does this mean for us? Gamma radiation is one of the most powerful forms of energy in the universe, and studying it can provide clues about the processes occurring in the galactic center. However, the question remains, could these bubbles have any impact on our galaxy or even on Earth? As scientists continue to investigate, they have discovered that the Fermi bubbles might be influencing the formation of new stars. The energy they emit can heat the surrounding gas, creating conditions that favor the creation of new stars. But how does this affect the balance of the galaxy? Could it be that the life of some stars depends on these bubbles in their environment? And that's not all. The Fermi bubbles may be related to other structures in our galaxy. Their shape has been observed to extend along the galactic plane, and some scientists are trying to determine if there is a connection with other energy regions. Could they be part of a larger system, a cosmic pattern that we have yet to decipher? Another intriguing question is whether these bubbles could be visible from other galaxies. If gamma radiation is so powerful, could it be detected by civilizations in other parts of the universe? This opens up a range of possibilities about how other forms of life might interpret our galactic home. Are we emitting signals to the cosmos unknowingly? As technology advances, so does our ability to study the Fermi bubbles. New telescopes and observation techniques are allowing scientists to observe these structures in greater detail. But despite these advances, the true mystery persists. Why do they exist, and what role do they play in the history of the Milky Way? It is fascinating to think that even though we live in a corner of the galaxy, these bubbles could be influencing the fate of our own existence. As new theories and discoveries emerge, more questions arise. Is it possible that one day we will fully understand the origin and function of the Fermi bubbles? The search for answers about the Fermi bubbles reminds us that the universe is a place full of surprises. Each discovery raises new questions and pushes us to keep exploring. While the Fermi bubbles are just one of the many wonders of the Milky Way, their study offers us a window into the cosmic processes that shape our galaxy. So what does all this mean for us, the inhabitants of Earth? In the end, these bubbles are not just a distant phenomenon, but a reminder of how little we truly know about the universe around us. Curiosity and the pursuit of knowledge are powerful forces that drive us to keep looking up, trying to understand our place in the vast cosmos. In summary, the Fermi bubbles are a fascinating mystery that remains to be solved. As we continue to observe and study, we get a little closer to unraveling the secrets of the Milky Way. But as in any good mystery story, the answers often lead to more questions, and that is what keeps our curiosity alive. Who knows what else we will discover in the future? Have you ever wondered why the Milky Way is not as flat as it seems? Although the classic image of our galaxy is that of a flat disk filled with stars, it actually has a more complex shape. This peculiarity is known as the mystery of galactic thickness, and it is an enigma that has intrigued astronomers for decades. The Milky Way has a thickness that varies depending on the region. In the center, where our supermassive black hole, Sagittarius A*, is located, the galaxy thickens noticeably. However, as we move away from the core, it becomes thinner, as if it were made of an undulating mass. Why does this happen? What forces are at play? One of the most fascinating theories suggests that gravitational interactions between stars could be responsible for this undulation. Stars are not fixed in place. They move and group together, creating currents and flows that affect the overall structure of the galaxy. However, it is still not fully understood how these dynamics affect galactic thickness. Could we be observing the imprint of past cosmic events that have shaped our galaxy? Another possibility is that the formation of new stars and the death of others influence the thickness. Supernova explosions, for example, could push matter outward, creating waves in the galactic disk. But what happens when a star dies? Do the remaining stars stay on the surface while the older ones descend to the depths? This exchange of matter could be one of the keys to solving the mystery. However, it is not just the stars that are responsible for this phenomenon. Dark matter, that mysterious substance that makes up most of the mass of the galaxy, also plays a crucial role. Although we cannot see it, its presence affects the movement of stars and could be influencing how they are distributed. What role does dark matter play in creating these undulations? Current models suggest that dark matter forms a kind of halo around the Milky Way, and its interaction with visible matter, including gas and stars, could be causing these thickness effects. But how can we study something we cannot see or touch? Astronomers use simulations and observations of stellar dynamics to try to decipher this relationship. Moreover, galactic thickness is not uniform throughout the Milky Way. Some regions are denser than others, and this may be due to the history of star formation in those specific places. For example, in areas where there has been significant star formation activity, there are likely to be more young stars and therefore greater thickness. But how do these variations relate to the evolution of our galaxy over time? As we continue to investigate, more questions arise. Are there differences in galactic thickness among different galaxies? Could there be a pattern that reveals the history of each one? The answers to these questions could help us understand not only our own galaxy, but also the universe as a whole. To complicate matters further, we must consider the impact of neighboring galaxies. Gravitational interaction with other galaxies, such as the nearby Andromeda, could be influencing how the Milky Way behaves and, consequently, its thickness. Are we witnessing the result of a cosmic dance that has lasted billions of years? In this sense, the mystery of galactic thickness is not only a challenge for modern astronomy, but also a window into the past of the Milky Way. Every star, every cloud of gas, every supernova explosion tells a story. The question is, are we ready to listen to it? Images of the cosmos reveal a panorama full of wonders, and the Milky Way is no exception. As telescopes become more powerful and our observation techniques improve, it is likely that more secrets about galactic structure will be unveiled. The thickness of our galaxy could be just the beginning of a series of discoveries that will change our understanding of the universe. Finally, let us reflect on the importance of this mystery. Understanding why the Milky Way has this thickness and how it has formed could be key to unraveling other enigmas of the cosmos. Every answer we find leads us to new questions, and that is what makes astronomy such an exciting and dynamic field. The exploration of the Milky Way is undoubtedly a journey that is just beginning, and the mystery of galactic thickness is just one of the many adventures that await us in the vast ocean of the universe. Hypervelocity stars are a phenomenon that sparks the curiosity of astronomers and those fascinated by the cosmos. Have you ever wondered how it is possible for some stars to move at such extreme speeds that they seem to be escaping our galaxy? This galactic enigma has puzzled scientists for years, and although there are several theories, there is still no definitive answer explaining their origin. Imagine a star traveling at more than 600 kilometers per second. In comparison, the Sun, which seems so constant in its trajectory, moves at a modest speed of about 200 kilometers per second in its orbit around the center of the Milky Way. But what drives these hypervelocity stars to break the gravitational chains of the galaxy? The answer may be related to close encounters between stars, or even the influence of a supermassive black hole. One of the most accepted theories suggests that these stars have been ejected from their places of origin, sometimes due to interactions with other celestial bodies. Imagine a group of stars in a cluster that, as they approach a black hole, experience such intense gravitational force that a few manage to escape while others remain trapped. This process creates what astronomers call a hypervelocity star. But is there any way to track these stars and understand their history? The search for these stars is not straightforward. Many of them are so far away that even the most powerful telescopes struggle to detect them. However, a recent discovery has revealed that some of these hypervelocity stars may be related to supernova explosions. After a stellar explosion, some stars may receive a push that sends them hurtling at incredible speeds. But is it possible that there is more than one mechanism at play? Another intriguing theory suggests that these stars could be the result of collisions between stars in binary systems. In this scenario, when two stars get close enough, they can collide, and as a result, one of them may be ejected at high speed. This process is not only fascinating, but also raises questions about the fate of the stars that do not manage to escape. What happens to them? Astronomers have identified hundreds of hypervelocity stars in the Milky Way, but the mystery remains deep. Although many of these stars appear to be on trajectories that take them out of the galaxy, could they be orbiting in the distant future? The nature of these stars is a reminder of how little we truly know about the universe. What other secrets might be hidden in the vastness of space? The existence of these hypervelocity stars also raises questions about the structure of the Milky Way. The way they unfold and distribute themselves could provide us with clues about the dynamics of our galaxy. Could their unexpected behavior be indicative of forces or structures yet to be discovered? The answers could change our understanding of the formation and evolution of galaxies. Thus, every time we observe the night sky, we might be seeing one of these hypervelocity stars traversing the vast and mysterious universe. And although many of them are moving away from us, their light still reaches us, telling stories of extraordinary journeys. What would they say if they could talk? The study of hypervelocity stars is not only a journey through time and space, but also a reminder of the beauty and complexity of the cosmos. Each discovery generates more questions, and the quest for answers becomes a thread that connects generations of astronomers. What new technologies or ideas could help us solve these enigmas? With each advance in astronomy, we are closer to unveiling the secrets surrounding these fast stars. Perhaps one day we will discover that some of them have a common origin, or that their existence is linked to even more astonishing galactic events. The exploration of the universe is an endless journey where each answer leads us to new questions. Hypervelocity stars are a testament to the dynamism of the universe. Their study not only illuminates our understanding of the Milky Way, but also invites us to look beyond, toward the infinite. What other wonders and mysteries await us in the vast darkness of space? Human curiosity drives us to keep searching, keep dreaming, and keep exploring. So, as we look up at the stars, let us remember that each point of light in the sky could be part of a story of speed, strength, and mystery. What other secrets will the Milky Way reveal to us in the future? The adventure is just beginning. Have you ever encountered the idea that there are planets that have no home to return to? In the vastness of our galaxy, there are solitary worlds wandering aimlessly, far from their original star systems. These are the orphan exoplanets, and their story is as fascinating as it is perplexing. But how is it possible for a planet to be so alone in the darkness of space? Exoplanets, those that orbit stars outside our solar system, are already a well-known and studied topic. However, there exists a group of planets that have been expelled from their systems, leaving them drifting in the vast galactic ocean. This raises an intriguing question. What forces or events could have led these worlds to lose their home? A collision with another planet? A gravitational disturbance from a nearby star? Scientists estimate that there may be more orphan exoplanets than planets still orbiting their stars. This revelation leaves us astonished. How is it possible that these planets, which once formed part of a system, are now completely alone? The answer may lie in the complex dynamics of planetary formation and gravitational interactions. In a star system filled with multiple bodies, movements can be chaotic, and sometimes planets are expelled at astonishing speeds. What kind of conditions can create an orphan planet? Imagine a system where several planets are orbiting a star. If one of them becomes unstable due to the attraction of another planet or the influence of a nearby star, it could be cast adrift. This expulsion can happen violently, and the planet, which once had a home, now finds itself on a solitary journey through the galaxy. But what happens to an orphan exoplanet on its journey through space? Without the light of a star to illuminate it, these worlds face an uncertain fate. They could be icy and dark, or perhaps their interiors still hold residual heat from their formation. Most will not experience life as we know it, but that doesn't mean they aren't interesting. Some scientists suggest that they could harbor underground oceans, keeping the possibility of life in environments very different from those we know. And what about their discovery? The search for orphan exoplanets is not straightforward. Most telescopes are designed to detect planets orbiting stars, so finding those that wander alone requires special techniques. Astronomers are using innovative methods to identify these worlds, such as observing the background light that bends around them. Thus, the existence of these planets becomes an exciting challenge for researchers. The question that arises now is, could these orphan exoplanets be a refuge for life? Although it is unlikely that they are similar to Earth, Science is beginning to consider scenarios in which life could arise under extreme conditions. Astrobiology invites us to think about forms of life that could adapt to entirely different conditions than those we know, opening a new horizon in the search for life in the universe. Some researchers believe that the existence of these orphan planets could offer important clues about the formation and evolution of planetary systems. By studying how and why they separate from their stars, we could better understand the processes that govern planet creation in the Milky Way. Each orphan exoplanet tells a unique story that, although lost in the vastness of space, may hold the key to unraveling the mysteries of our galaxy. Ultimately, the existence of orphan exoplanets reminds us of how small we are in the vast universe. As we gaze at the starry sky, we might find a solitary world that, despite its isolation, carries with it the story of its past and questions about its future. Perhaps one day we will understand more about these wandering worlds and what they can teach us about life and the cosmos. So the next time you look up at the stars, think of those planets traveling alone in their eternal search for a home. The Milky Way is a place full of surprises and mysteries, and each of these orphan exoplanets is a reminder of what we still have left to discover. The exploration of the universe is just beginning, and each of these planets is a window into the unknown, an enigma waiting to be solved. What are the Magellanic Clouds and why are they so fascinating? These two satellite galaxies, known as the Large Magellanic Cloud and the Small Magellanic Cloud, are like the little sisters of our Milky Way. But how did these galaxies come to be so close to us, and what role do they play in our galaxy? Located about 160,000 light-years away, these clouds are a window into the past. They are thought to contain gas and dust that could be feeding the Milky Way. But where does this gas come from? Some scientists believe it formed from the explosions of stars in the past. However, this theory does not explain everything. The truth is that there are still many mysteries to uncover about their origin. The Magellanic Clouds are not only important because of their proximity, but also for what they teach us about galaxy formation. These small galaxies have witnessed the history of our own galaxy over billions of years. How do they influence the formation of new stars in the Milky Way? The answer to this question is complex. It is believed that the clouds may be contributing hydrogen gas, the basic material for star formation. But how much gas do they really provide? The Large Magellanic Cloud, for example, has dense regions of gas that, in theory, could trigger the formation of new stars. This raises an intriguing question. Could these clouds be the birthplace of stars that will eventually become part of our galaxy? If this is true, we would be witnessing a continuous cycle of creation and destruction where the clouds feed the Milky Way with fresh material. Moreover, did you know that the Magellanic Clouds also have their own history of collisions? It has been discovered that they have interacted with the Milky Way in the past, and these interactions may have influenced their current shape and structure. The gravitational forces between galaxies can be intense, creating a cosmic dance that lasts millions of years. How will this affect the evolution of the Milky Way in the future? Another fascinating aspect of the Magellanic Clouds is their stellar population. These galaxies host a large number of young, bright stars. However, why are they different from the stars in the Milky Way? Many astronomers think that these stars formed in a different environment, which could be explained by the varying amounts of gas and dust available in the Large and Small Magellanic Clouds. As we delve deeper into the study of these clouds, we encounter an even more intriguing phenomenon: the presence of heavy elements. Where do they come from? It is believed that these elements were generated in the interiors of stars that exploded as supernovae in the past. This leads us to another question. Could the Magellanic Clouds be a natural laboratory for studying the chemical evolution of the universe? The clouds are also an ideal place to observe astronomical phenomena. Did you know they are home to one of the closest supernovae we have been able to study? Supernova 1987A, which was found in the Large Magellanic Cloud, has provided valuable information about the life and death of stars. This type of observation helps us better understand not only the Magellanic Clouds but also our own galaxy. Through powerful telescopes, we have been able to observe how these clouds are changing. But what does this mean for the future of the Milky Way? If the Magellanic Clouds continue to interact with our galaxy, we might see an increase in star formation in our region. This could enrich the star population and ultimately influence the evolution of our galaxy. In this vast sea of stars and gas, there are also mysteries that we have yet to solve. Some theories suggest that the Magellanic Clouds could be linked to other galaxies in the universe. Could they be part of a larger group of galaxies? This is an active area of research in the field of astronomy. Finally, the importance of the Magellanic Clouds goes beyond their proximity to the Milky Way. They are a reminder that there is much more to discover in the universe. Every new star that is born, every supernova that explodes, and every galactic interaction offers us clues about how the cosmos works. What other mysteries will the Magellanic Clouds reveal to us in the future? In summary, the Magellanic Clouds are more than just simple nearby galaxies. They are key pieces in the puzzle of the Milky Way. With each discovery, we get a little closer to understanding not only their history, but also that of our own galaxy. And so we continue to look to the sky, hoping it will tell us more about its vastness and its secrets. What would happen if I told you that deep within the Milky Way there are stars that seem to have devoured others? This phenomenon, which may sound like something out of a science fiction movie, is known as cannibal stars. But how does this happen, and why is it so intriguing to astronomers? Cannibal stars are celestial bodies that, when they approach other stars, can absorb some of their material. This process is not just an act of stellar hunger, but reveals much about the dynamics and evolution of our galaxy. Generally, stars exist in a delicate balance, but under certain circumstances this balance is disrupted. What factors could lead a star to become a cannibal? First, let's talk about dwarf stars. These small and relatively cool stars can be devoured by larger stars. Imagine a giant star approaching a dwarf, drawn in by its gravity. As they get closer, the giant star begins to siphon gas and material from the dwarf, a process that can continue until the dwarf becomes a shadow of what it once was. But is it just the size difference that matters in this cosmic dance? Cannibal stars can also be found in binary systems, where two stars orbit each other. As one of the stars evolves and expands, it may begin to eat its companion. This type of interaction can lead to one star becoming extremely bright and massive, while its partner slowly fades away. Isn't it fascinating to think that there could be a cosmic feast happening in real time in the universe? Moreover, the environment in which these stars form is crucial. In dense regions of the galaxy, where stars are more clustered, gravitational interactions are more frequent. This increases the likelihood of a cannibal star forming. In these stellar neighborhoods, competition for resources can be fierce. But how can we observe these interactions from so far away? Astronomers have turned to the light emitted by these cannibal stars to study them. When one star devours another, enormous amounts of energy are released, often in the form of bright light and radiation. This light is a clue that allows us to detect cannibal stars, even if they are thousands of light years away. Can you imagine how many of these stars might be hiding in the shadows of our galaxy? However, it's not all straightforward. Determining which stars are cannibals is not an easy task. Many times the stars that are eating others do not show obvious signs of their cannibal activity. Sometimes, astronomers must rely on theoretical models and simulations to understand these processes. What else might they be discovering as they delve deeper? On the other hand, these cannibal stars may play a fundamental role in the evolution of the galaxy. By consuming other stars, they contribute to the creation of new stars and the dispersion of elements in space. This means that, in a way, the life cycle of stars is interconnected. What implications does this have for the formation of new planetary systems? The story of cannibal stars also invites us to reflect on the nature of life in the universe. Could it be that in other corners of the cosmos there are even more voracious stars than ours? The quest for answers about these phenomena leads us to question how the universe truly works. As telescopes become more powerful and technology advances, scientists continue to uncover more about these cannibal stars. What surprises does the future hold for us? Perhaps we will discover that there is more than we can imagine in the vast ocean of stars that surrounds us. This phenomenon reminds us that the Milky Way is a place full of secrets and mysteries. Cannibal stars are just one of the many stories hidden in its depths. So the next time you look up at the sky, think about the battles being fought in the silence of space, where stars feed on one another in an endless cycle of life and death. The galaxy is a place where beauty and danger coexist, and cannibal stars are a reminder that in the universe nothing is as it seems. In every corner of our Milky Way, stars continue their dance, some devouring, others being devoured. The curiosity about these phenomena drives us to keep exploring and learning. What other secrets will the universe reveal to us in its vastness? The answer is waiting to be discovered. In the vast universe of astronomy, there are phenomena that surprise us and leave us with more questions than answers. One of those fascinating mysteries is the enigma of the missing supernovae. Have you ever wondered why? Despite predictions, we haven't seen as many stellar explosions as we expected in our galaxy. The Milky Way, with its beauty and complexity, should be a place filled with these impressive detonations. However, astronomers have encountered a surprising absence of supernovae compared to what was anticipated. To understand this mystery, we must first remember that supernovae are colossal explosions that mark the end of the life of a massive star. These explosions are not only spectacular but also play a crucial role in the formation of new elements. So how is it possible that we are not seeing enough of them in our own galaxy? This has led scientists to wonder, are we observing the universe incompletely? One factor that could explain this anomaly is the way supernovae are formed. Normally, it is expected that massive stars, those that have at least 8 times the mass of our Sun, end their lives in this explosive manner. But where are all those massive stars? Is it possible that many of them have collapsed into black holes, leaving behind silence instead of a spectacular supernova? This is a dilemma that astronomers are trying to solve. Additionally, some suggest that the Milky Way might be in a less active phase of star formation. If our galaxy is in a period of calm, that could mean that supernovae are not as common as once thought. But how do we know if this is true? The answer lies in the study of young stars and their trajectories. Astronomers observe that most of the explosions detected in other galaxies come from regions where new stars are forming. So, could it be that our galaxy has fewer star formation areas than we imagine? Theoretical models also provide valuable insights. Some scientists believe that the Milky Way could be eating smaller galaxies, which could affect the number of supernovae we observe. This idea leads us to think about the dynamics of our galaxy. Is it possible that events occurring in the vast space around the Milky Way influence stellar explosions? The answer may lie in the interaction of matter and energy in the cosmos. On the other hand, the Hubble Space Observatory has provided fascinating data that allows researchers to study supernovae in other galaxies. Thanks to this technology, scientists have been able to observe over 1,000 supernovae in nearby galaxies. However, when looking toward our own Milky Way, we have only detected a small number in recent centuries. Where have those explosions gone? Perhaps the answer is even more intriguing than we think. Another avenue of research focuses on time. Supernovae do not occur instantaneously. The life of a massive star can last millions of years before it finally explodes. This leads us to wonder, could we simply be in a cycle of low activity? Supernovae are relatively rare phenomena on astronomical timescales, and perhaps our observation has been too short to capture the true rhythm of these explosions. Moreover, astronomers are beginning to consider the role of dark matter. Although we cannot see dark matter, we know it is present and represents a significant part of the universe. Could this mystery of dark matter be related to the lack of supernovae in our galaxy? Perhaps the influence of dark matter on the dynamics of stars and their evolution is a factor we have yet to fully understand. As scientists continue their search, we cannot help but wonder about the impact that supernovae have on the universe. Each explosion not only marks the end of a star, but is also responsible for the creation of new elements that form planets and ultimately life itself. Without supernovae, what would the universe be like as we know it? This question leads us to consider the role these explosions play in cosmic history. Advancements in technology also play a crucial role in the search for answers. With more powerful telescopes and satellites in space, astronomers are better equipped than ever to observe astronomical phenomena. However, the lack of supernovae in the Milky Way remains a puzzle. As science progresses, so does our understanding of the processes that govern the universe. The search for missing supernovae continues, and each answer leads us to new questions. In summary, the mystery of the missing supernovae in the Milky Way is a reminder of how little we know about our own galactic home. With each discovery, we get closer to unraveling the secrets of our galaxy while new uncertainties emerge. The next time you look at the starry sky, remember that each star has a story to tell, and perhaps, somewhere in the vast cosmos, a supernova is waiting to be discovered. The search for answers continues, and the universe has much more to offer. When we observe the night sky, we often marvel at the vastness of the universe, but there is a particular phenomenon in our galaxy that sparks the curiosity of scientists and astronomy enthusiasts: the Gould Belt. What exactly is this mysterious collection of young stars? Why does its formation remain an enigma? To begin with, it is essential to understand that the Gould Belt is an arc of stars that stretches across the sky near our Sun. It stands out due to its peculiarity, as these stars are much younger compared to many of their neighbors. But how is it possible for such a young group of stars to be so close to us, yet their origin remains a mystery? One of the most intriguing questions about the Gould Belt is how it formed. The theories vary, but many astronomers believe that these stars formed in a massive stellar creation event. However, there is no consensus on when this event occurred. Some suggest it may have happened about 1 billion years ago, while others believe it could have been more recent. How can it be that a collection of stars so close to us has such a diffuse and debated origin? As scientists study the Gould Belt, they realize that these are not just isolated stars. This belt seems to be part of a larger structure in the galactic disk of the Milky Way. But what does this mean in terms of our understanding of the formation and evolution of the galaxy? If these stars are part of a larger group, what other wonders might be hidden within it? A fascinating aspect of these stars is their composition. The stars of the Gould Belt are primarily of spectral type A, which means they are brighter and hotter than the Sun. But what does this imply for their life cycle? Since they are younger, they are likely in the early stages of their lives, providing us with a unique opportunity to study how stars form and evolve in our galaxy. Moreover, the location of the Gould Belt raises another intriguing question. Why are these stars not distributed evenly across the sky? Instead, they cluster in a distinctive arc. This distribution could be related to gravitational forces and the dynamics of the Milky Way. But how do the interactions of other stars and gas clouds influence the formation and position of the belt? As we explore further, we encounter the possibility that the Gould Belt may be a remnant of an ancient supernova explosion. Could it be that what we see today is the result of the explosion of one or more massive stars? This could have created a favorable environment for the formation of new stars in the region, but then, why do we not find more concrete evidence of that explosion? Research on the Gould Belt also leads us to consider its relationship with other galactic structures. For example, could it somehow be connected to the halo of old stars surrounding the Milky Way? The interaction between these different stellar populations could offer clues about the tumultuous past of our galaxy. What secrets will the study of these connections reveal? It is fascinating to think that, despite advances in modern astronomy, there is still so much we do not know about the Gould Belt. Each new discovery raises more questions than answers, reminding us of how dynamic and complex the Milky Way is. As we improve our observational tools and techniques, it is possible that one day we will unravel the secrets of this enigmatic belt. On the other hand, the Gould Belt is not only a subject of study for scientists, but also a reminder of our own position in the cosmos. These young, bright, and energetic stars represent a constantly changing future and a cycle of renewal in the universe. Is there a message in their light about our own place in the vastness of the galaxy? The quest for answers about the Gould Belt also highlights the importance of collaboration within the scientific community. Astronomers from around the world work together, sharing data and ideas in an effort to unravel the mysteries of the universe. This collective effort is what drives human knowledge forward, and the Gould Belt is just one example of how there are still many pages to be written in our understanding of the Milky Way. So the next time you look up at the sky and see that arc of stars, remember that each one has its own story. The Gould Belt is a reminder that, although there is much we do not understand, the journey toward knowledge is as exciting as the discoveries themselves. What other secrets might the Milky Way reveal in the future? The answer lies on the horizon, waiting to be discovered. Second-generation stars are a true mystery in the vast cosmos. But what exactly are they? These stars are those that formed after the explosions of the first supernovae, the titans of the universe that mark the end of the lives of the most massive stars. However, a fascinating question arises here. Where do the materials that gave life to these new stars come from? To understand this, we must go back in time to the moments immediately following the formation of the universe. After the Big Bang, the universe was filled with hydrogen and helium, the simplest elements. Over time, some of these first stars were born, shining brightly and eventually exploding in supernovae. These explosions were not only spectacular but also released more complex elements, such as carbon, oxygen, and iron, into space. But why is this so important? Because those elements are the building blocks of new stars and potentially planets. The question many astronomers ask is, what is the relationship between second-generation stars and the first stars? The answer may lie in the star formation environment of the galaxy. Second-generation stars tend to have fewer metals, meaning fewer heavy elements, than their predecessors. This makes them true relics of the past, offering clues about the chemistry and evolution of the universe. But how can we study these ancient and distant stars? Astronomers use powerful telescopes and spectroscopy techniques to analyze the light emitted by these stars. By breaking down the light into its components, they can identify the signature of different chemical elements. However, many of these stars are faint and difficult to observe, adding a level of complexity to their study. So, what do these observations really tell us about the history of our galaxy? Recent research has revealed that some second-generation stars may have formed in more violent environments where the energy from nearby supernova explosions contributed to the formation of new stars. This raises an intriguing question. Were these stars witnesses to cataclysmic events in their early moments of life? Imagine being in the place where a supernova has just occurred. The energy released could have influenced the creation of new stars in its vicinity. Furthermore, second-generation stars also allow us to explore the evolution of the Milky Way. As our galaxy grew and merged with smaller galaxies, the stars that emerged from those events may have become part of our own history. So how many of these second-generation stars currently orbit our Sun, invisible to the naked eye? One of the most intriguing theories is that some of these stars could be part of globular clusters, which are dense groups of stars that orbit the Milky Way. If this is true, we might be close to a true time capsule, observing groups of stars that formed in the early stages of the universe. What secrets do these ancient star clusters hold? But the story doesn't end there. The search for second-generation stars is also related to dark matter. As researchers study the distribution of these stars, they wonder how dark matter has influenced star formation. Could it be that dark matter played a crucial role in the creation of these stars? The answer could redefine our understanding of galaxy formation. Another fascinating aspect of second-generation stars is their potential to harbor life. Although these stars themselves may not be the ones that could host habitable planets, Studying their formation and composition can provide clues about how planetary systems formed in general. Could it be that by better understanding these stars, we are also one step closer to discovering how life arose on other worlds? The fact that these stars are less metallic also raises questions about the possibility of finding planets in systems orbiting these stars. Will the conditions be suitable for the development of life? Research continues, and each new discovery in this field could be another piece in the puzzle of life in the universe. Science is advancing rapidly, and new technologies such as space telescopes are expanding our horizons. More and more, astronomers are encountering the possibility of discovering second-generation stars in places that were previously unreachable. What new surprises does the cosmos hold for us as we progress in our exploration? The search for answers about second-generation stars is a journey that connects us with the history of the universe. It reminds us that we are part of something much larger, a vast tapestry of stories intertwined through time and space. Each star is a page in the book of the cosmos, and there is still much to read. So do you dare to continue exploring the mysteries of the Milky Way and beyond? Each question can lead us to new revelations. And each discovery can change the way we understand our place in the universe. In the vast and fascinating cosmos of our Milky Way, there is an intriguing trail that speaks to us of a distant past. We are talking about the Sagittarius stream, a phenomenon that reveals the remnants of a galaxy that was absorbed by ours. But why is this stellar stream so important? What secrets does it hide in its glow? Imagine a river of stars flowing in the depths of space, a golden thread that connects fragments of a forgotten story. This stream, composed of thousands of stars, is the result of the devouring of a dwarf galaxy that once orbited the Milky Way. But how did we know that this galaxy existed? Astronomers have studied the stars that form this stream, and by analyzing their chemical composition, they have discovered that they are very different from the stars we know. This suggests that they belong to a distinct place, a world that no longer exists. The Sagittarius stream is like an ancient book whose content has been lost, but whose fragments we can still read. Scientists have identified that this stream extends across a large part of the sky, and each star in it tells a story. But what else lies behind this enigma? Most of these stars are young and bright, making them stand out in the vast ocean of stars in our galaxy. However, their speed and direction reveal that they are not part of the original fabric of the Milky Way. What impact did this dwarf galaxy have on the structure of our own galaxy? It has been speculated that its absorption not only brought stars but also gas and dust, crucial elements for the formation of new stars. But how many more galaxies might have met the same fate? The Milky Way is a true cosmic eater, and every time it devours a galaxy, it enriches itself with new stars and materials. But what happens to the galaxies that remain? Are they simply devoured without a trace? As we delve deeper into this mystery, we encounter another fascinating aspect: the way the Sagittarius stream has persisted over time. The gravitational forces of the Milky Way have shaped its trajectory, but they have also left their mark on the stream itself. How is it possible that these stars remain united despite being part of such a tumultuous past? The answer lies in the strength of gravity, which acts as an invisible bond that keeps these stars together, even as they move through space. But the mystery doesn't end there. As the stars of the Sagittarius stream interact with other stars and galactic structures, they can also participate in spectacular events. What happens when these stars approach other stars or even black holes? Astronomers are discovering that these interactions can trigger bursts of light and energy, creating astronomical phenomena that leave us breathless. The Sagittarius stream is not just a simple trail of stars, it is a window into the galactic past. It allows us to glimpse how the Milky Way has grown and evolved over billions of years. But what more can we learn from it? Each new discovery about this stream can offer clues about the future of our galaxy. If the Milky Way continues to devour dwarf galaxies, what shape will it take in the next billions of years? As scientists study this stellar stream, They also face challenges. Detecting these stars is not easy. They hide among billions of others, and it is often complicated to discern their origin. What technologies are astronomers using to solve this puzzle? With advanced telescopes and data analysis techniques, they are unraveling the secrets of the Sagittarius stream, revealing more about its composition and trajectory. The Sagittarius stream also raises questions about the future of our own galaxy. If this phenomenon is a sign that the Milky Way is in constant change, what will our destiny be in the vast cosmos? As time goes on, and if we continue to observe and learn, perhaps we can foresee how the Milky Way will transform in a distant future. In every corner of the universe, there are stories waiting to be told, and the Sagittarius stream is just one of them. It reminds us that, although we are small compared to the immensity of the cosmos, each star, each galaxy, has a role in the narrative of existence. In this cosmic dance, our home in the Milky Way remains a mystery to be solved, full of enigmas and wonders that still await us. So, the next time you look up at the night sky, think of the stories hidden among the stars. The Sagittarius stream is just one of the many currents flowing in the vast ocean of space. Each star has a past, and each flicker of light is a reminder that the universe is full of surprises. Thus, as we continue to explore, let us never stop asking, what other secrets will the Milky Way reveal to us? What are globular clusters and what secrets do they hold within? These mysterious groups of stars give us clues about the history of our galaxy. Imagine spheres composed of thousands and even millions of stars orbiting around the center of the Milky Way. But how did they form, and what is their importance in understanding the cosmos? Globular clusters are one of the oldest components of our galaxy, and they are believed to have formed in the early stages of the universe. However, many questions remain. For example, why are there so many globular clusters in the Milky Way but not in other galaxies? Some theories suggest that these clusters could be the remnants of older galaxies that were absorbed by the Milky Way in the distant past. Could they hold the key to understanding the evolution of our galactic home? Most of these globular clusters are compact and bright spheres that orbit in a halo around the galaxy. However, their density and distribution are not uniform. Why are some clusters seemingly grouped in certain regions while others are more dispersed? This could be due to gravitational interactions with other stars and clusters, complicating their history even further. One of the most intriguing questions is, what happens inside a globular cluster? The answer is fascinating. In these clusters, the stars are so close to each other that gravity plays a crucial role. Sometimes larger stars can attract smaller ones. This phenomenon is known as stellar cannibalism. But how do we know this happens? Through observations, astronomers have detected stars that appear to be older and that have undoubtedly absorbed others during their lifetime. Additionally, some globular clusters may be home to unusual stars, such as millisecond pulsars which spin at incredible speeds. What makes them so special? These stars form when a companion star siphons off material from them, increasing their rotation to extraordinary levels. Could these phenomena give us clues about the life and death of stars in the universe? Research on globular clusters has also revealed valuable information about dark matter. It has been found that the distribution of stars within these clusters may indicate the presence of dark matter that we cannot see. What does this mean for our understanding of the universe? This discovery suggests that dark matter influences the formation of galactic structures, but many questions remain unanswered. Another intriguing issue is how these globular clusters have remained intact over billions of years, despite gravitational forces and collisions with other stars and clusters. What makes them so resilient? Some scientists believe that their density and the gravitational interaction between stars provide them with a kind of shield that allows them to survive the adversities of space. Globular clusters are also important for understanding the age of the Milky Way. By studying the oldest stars in these clusters, astronomers can estimate the age of the galaxy itself. What secrets about the past of the Milky Way could be revealed through these ancient stars? Each star in a globular cluster can tell a story of events that occurred in the early universe. The diversity of globular clusters is astonishing. Some are richer in metals while others are practically pure. How does this influence the formation of new stars? The chemical composition of a globular cluster can affect the conditions necessary for new celestial bodies to form. By studying these elements, scientists can learn more about how galaxies have developed over time. The relationship between the Milky Way and its globular clusters also gives us clues about the future fate of our galaxy. What will happen to these clusters when the Milky Way collides with the Andromeda galaxy? They could be absorbed or even disintegrated. Such galactic interactions could unleash a series of events that would change the face of our galaxy forever. Yet, despite all we know, globular clusters remain a mystery. Each new discovery raises more questions about how they formed, how they evolve, and how they interact with our galactic environment. Will these clusters be the key to unraveling the deepest secrets of the Milky Way? With each advancement in observational technology, from ground-based telescopes to space probes, information about globular clusters becomes increasingly accessible. Each image and piece of data collected brings us one step closer to understanding the vast and complex universe in which we live. So the next time you look up at the starry sky, remember that among those twinkling lights may lie echoes of past ages, hiding secrets that are still waiting to be discovered. Globular clusters are just a part of the intricate puzzle of the Milky Way, and each one has its own story to tell. What new mysteries will they reveal in the future? The exploration of the cosmos is just beginning. What is really hidden in the heart of our galaxy? At the center of the Milky Way lies an enigmatic black hole known as Sagittarius A*, a true cosmic titan. But how do we know it's there? The answer lies in the movement of the stars that orbit around it. Through careful observations, astronomers have been able to deduce that these stars move at incredible speeds, suggesting the presence of an enormous mass concentrated in a very small space. But what does all this mean? Imagine a whirlpool in a river. The water swirls and moves quickly toward the center where there is a huge void. Similarly, the stars orbiting Sagittarius A* seem to be drawn toward this mysterious entity that we cannot see, but whose gravitational force is undeniable. What if I told you that this black hole has a mass equivalent to 4 million times that of the Sun? That's a hard number to imagine, but think about how many suns could fit inside it. The gravity it exerts is so powerful that nothing, not even light, can escape its pull. But how did Sagittarius A* form? Astronomers have several theories. Some believe it formed from the collision and merging of smaller stars, while others suggest it could have arisen from a massive collapse of gas and dust in the center of the galaxy. However, so far we have not found a definitive answer. Isn't it fascinating to think that the center of our galaxy is a place where such extreme and mysterious processes have taken place? As we delve deeper into this enigma, another question arises. What effects does Sagittarius A* have on the Milky Way as a whole? Its enormous gravity influences the movement of stars and gas in its vicinity, creating a dynamic environment. Moreover, it has been discovered that this black hole is not just a passive entity. Sometimes it emits powerful jets of energy and matter into space, creating phenomena that extend far beyond its neighborhood. Can you imagine what it must be like to observe one of these jets? The energy released could be enough to illuminate vast regions of space. The existence of Sagittarius A* also raises questions about its relationship with other galaxies. Some theories suggest that supermassive black holes like this one may play a crucial role in the evolution of galaxies. They could be involved in star formation and gas dynamics, acting as a regulator of galactic activity. Is it possible that the life of our galaxy depends on this dark colossus? And here is where the story becomes even more intriguing. As astronomers continue to study Sagittarius A*, they have begun to notice strange behaviors. Some indicate that its activity might be changing, leading us to wonder, is it waking up? Could there be a future in which this black hole becomes even more active, affecting the dynamics of the Milky Way in ways we cannot yet predict? Speaking of the future, it's important to consider how these mysteries might influence our understanding of the universe. Research on black holes has led to revolutionary discoveries in physics and cosmology. Each new finding brings us closer to answering fundamental questions about the nature of space and time. What more could we learn from this dark colossus residing in the heart of our galaxy? Research on Sagittarius A** is not only fascinating from a scientific perspective, but it also sparks our imagination. Thinking about a place where time and space behave differently invites us to reflect on our place in the cosmos. What does it mean for us to know that at the center of our own galaxy, there is such an extreme and unknown phenomenon? Finally, let's consider how the exploration of Sagittarius A* can inspire future generations of scientists and dreamers. Each discovery about this black hole brings us closer to understanding the deepest mysteries of the universe. So the next time you look up at the sky, remember that in the heart of our galaxy there is a titan that continues to hold secrets. What more will it reveal to us in the future? The story of Sagittarius A* is just one of many that make up the vast and fascinating puzzle of the Milky Way. Each mystery we solve leads to new questions, and each answer opens the door to new explorations. The quest for knowledge about our universe is endless, and it is a journey worth undertaking. So stay curious and keep looking up at the stars, because the cosmos always has more surprises to offer. Did you know that our Milky Way is on a collision course with the Andromeda Galaxy? This encounter, expected to happen in about 4 billion years, raises fascinating questions about the future of our cosmic home. What will happen to the stars and solar systems we know today? The collision between these two gigantic galaxies is an inevitable event, and while it may seem frightening, we need not worry. The distances between stars are so vast that direct collisions between them are unlikely. But what does this galactic merger really mean? It's like two great cities coming together, but instead of buildings crashing, it's billions of stars that are meeting. When Andromeda and the Milky Way merge, astronomers believe a new galaxy will form, possibly as a result of a spectacular cosmic dance. Can you imagine what the sky would look like from Earth at that time? The constellations we know would change, and we might see new stars and nebulae that we have never contemplated before. However, for those of us living on Earth, this transformation will be so gradual that we probably won't even notice what is happening. As the two galaxies approach, they will begin to gravitationally influence each other. This means that the stars of Andromeda will be attracted by the gravity of the Milky Way and vice versa. Can you imagine the mix of stellar dust and gas that will be generated in the process? The new stellar formation environments could lead to the creation of new stars at an accelerated rate, which could be an impressive spectacle on the vast canvas of the universe. As the galaxies merge, complex structures are expected to form. Some theories suggest that new spiral arms will be generated, and we could witness the birth of star clusters that we have never seen before. What secrets could this new galaxy reveal? Perhaps new forms of life on worlds we have yet to imagine. However, not everything is rosy in this galactic collision. Some stars could be thrown into intergalactic space, drifting away from their original home. This raises the question: what will happen to the solar systems that depend on the gravitational stability of their galaxy? While these systems may survive, some could face an uncertain future. One of the most intriguing aspects of this collision is the fate of our Sun. Will it survive this merger? Most scientists believe it will, as the Sun is in a stable orbit. However, its position in the new galaxy could change. How will this affect Earth and life as we know it? This is a mystery that only time can resolve. The study of the collision between the Milky Way and Andromeda also provides us with a unique opportunity to learn about the structure and evolution of galaxies. By observing this encounter, astronomers hope to gain insights into how galaxies form and evolve over time. Could this help us better understand the history of our own Milky Way? Galactic mergers are not a rare phenomenon in the universe. In fact, it is estimated that most galaxies have undergone similar processes in their history. So, as we contemplate our galactic future, we are also invited to reflect on the past of other galaxies. What stories behind these mergers are still waiting to be discovered? The data obtained from the collision will help us answer other questions. For example, what role does dark matter play in these interactions? Although we cannot see dark matter, we know it is present and influences the gravity of galaxies. Could it be that this encounter between the Milky Way and Andromeda offers us additional clues about this mysterious substance? As we approach the date of the collision, curiosity about what is to come continues to grow. What will happen if, in the future, we detect other celestial bodies that are also heading towards us? Could it be that the universe is full of surprises waiting to be discovered? Ultimately, the collision of the Milky Way with Andromeda is a reminder of how dynamic and ever-changing our universe is. Each new discovery about this encounter not only helps us better understand our own galaxy, but also the place we occupy in the vast cosmos. With each answer, more questions arise, leading us to continue exploring and learning about the enigma of galactic existence. So, as we look up at the stars, let us remember that the future of our galaxy is in constant evolution. And although the collision with Andromeda may seem like a distant event, it is an opportunity to marvel at the grandeur of the universe and its intricate dance. What exactly are the satellite dwarf galaxies of the Milky Way? These small galaxies that orbit our own galaxy are a true mystery. Although they are tiny compared to the Milky Way, their existence raises fascinating questions about the formation and evolution of galaxies in the universe. How have these dwarf galaxies managed to stay bound to the Milky Way for billions of years? The first of these dwarf galaxies to be discovered was the Sagittarius dwarf galaxy, which was identified in 1994. Since then, several more have been found, such as the Ursa Minor galaxy and the Carina galaxy. But why are these galaxies so difficult to observe? They are often so faint that they require powerful telescopes and ideal conditions to be seen. What secrets might they hold within? An intriguing aspect of the satellite dwarfs is their composition. Many of them are primarily made up of dark matter, that mysterious substance we cannot see but seems to influence the gravity of galaxies. Could it be that these dwarfs are remnants of past epochs, fragments of larger galaxies that have worn down over time? This scenario leads us to wonder what other secrets await in the darkness of space. As the satellite dwarfs orbit the Milky Way, they are subjected to gravitational forces that affect them in surprising ways. Some of these galaxies are being slowly stripped of their matter as if the Milky Way is eating them. This raises a fascinating question. Is it possible that the Milky Way is in a constant state of galactic cannibalism? This phenomenon not only challenges our understanding of galaxies, but also suggests that the Milky Way has had a complex and dynamic history. Moreover, the satellite dwarfs may offer clues about the formation of the Milky Way itself. By studying their composition and orbital trajectory, astronomers can gain valuable insights into the history of our galaxy. What will these small worlds tell us about the conditions of the early universe? With each discovery, we get a little closer to understanding how our galaxies formed and how they have evolved over time. But the search for these galaxies is not just about understanding the past. By observing how they interact with the Milky Way, scientists are trying to unravel the mysteries of dark matter. Could it be that these dwarfs are showing us how dark matter is distributed in the universe? The answer to this question could have profound implications for our understanding of the cosmos. Despite advances in technology and astronomy, many of these satellite dwarfs remain an enigma. Some are so small and faint that current telescopes can barely detect them. This means there may still be many more waiting to be discovered in the darkness of space. How many more dwarf galaxies could be orbiting the Milky Way without us knowing? Only time and ongoing research will tell. What is fascinating about the satellite dwarfs is that, despite their size, they have a significant impact on our understanding of the Milky Way. Their study not only reveals details about the structure of our galaxy, but may also provide clues about how galaxies behave in the universe at large. Could it be that these small dwarf galaxies are playing a crucial role in cosmic history? Another intriguing question is, why do some satellite dwarfs appear to be more alive than others? Some of these galaxies are still forming new stars, while others seem to have exhausted their supply of gas and dust. This diversity in behavior suggests that each dwarf has its own story to tell. What events might have influenced their evolution and development over time? The mysterious relationship between the Milky Way and its satellite dwarfs also raises questions about gravity and galactic dynamics. How do these small galaxies manage to maintain their orbit amid the gravitational pull of a much larger galaxy? The answer to this question could provide key insights into how galaxies interact with each other and how new stellar systems are formed. Finally, as we continue to explore the universe, the search for satellite dwarfs reminds us that there is still much to discover. Each small advance in our understanding of these dwarf galaxies brings us one step closer to unraveling the mysteries of the Milky Way and the cosmos as a whole. What new surprises await us in the vast and dark space? The adventure of galactic exploration is far from over. The Milky Way, that vast and mysterious place where our home resides, holds secrets that intrigue us deeply. One of the most fascinating is the enigma of dark matter. What exactly is this substance that seems to make up most of our galaxy? Yet we have never been able to observe directly. It is a question that has puzzled astronomers and scientists for decades. It is estimated that around 95% of the mass of the Milky Way does not emit light or radioactivity, which means we cannot detect it with our telescopes. So how do we know it is there? Scientists have reached this conclusion through indirect observations. By studying the movement of stars and galaxies, they have noticed that there is more gravity acting on them than would be possible if we only considered visible matter. This phenomenon suggests that something invisible, a kind of cosmic shadow, must be present. But why is it so difficult to detect? The answer may lie in its very nature. Dark matter does not interact with light like we do, making it elusive and almost ghostly. Some researchers have proposed that dark matter could be composed of unknown particles. There are theories suggesting that these particles, called WIMPs, could be responsible for the additional gravity we observe, but so far no experiment has managed to capture a single one of these particles. Can you imagine how exciting it would be if one day we could confirm their existence? That would completely change our understanding of the universe. The search for dark matter is not limited to the Milky Way. In the vast cosmos, evidence has been found suggesting that dark matter plays a crucial role in the formation and evolution of all galaxies. So if dark matter is so fundamental, why have we still not been able to unravel its mystery? The answer may lie in the complexity of interactions in the universe. The physics we know may not be sufficient to explain what happens on such large scales, but not all is lost. Science is constantly advancing, and new technologies and experiments are being developed every day that could help us illuminate this dark corner of the cosmos. For example, underground detectors designed to trap WIMPs are operational, and some have reported intriguing, though still inconclusive, results. Could these experiments be the key to finally seeing what has been hidden from our eyes? Moreover, astrophysical research not only focuses on dark matter, but also on how it influences the structure of the Milky Way. Computer simulations have revealed that dark matter acts as an invisible skeleton that supports galaxies and their clusters. Without it, our galaxy might not have reached the shape it has today. Isn't it impressive to think that what we cannot see is, in fact, what shapes our cosmic home? The relationship between dark matter and visible matter is a fertile field of study. Researchers strive to understand how both interact and how this interaction has influenced the creation of stars and planets. Could dark matter have played a role in the birth of our own solar system? Each new answer brings more questions, creating an endless cycle of discovery. There are even those who believe that dark matter could be related to even stranger phenomena, such as dark energy. This mysterious force seems to be accelerating the expansion of the universe. Could it be that both dark matter and dark energy are two sides of the same cosmic coin? This is another of the big questions scientists seek to answer as they try to unravel the secrets of the Milky Way. Meanwhile, the study of dark matter also offers us a unique opportunity to reflect on our own existence. By seeking to understand what we cannot see, we push ourselves to question our place in the universe and what we really know about it. Is there more in the cosmos than what our senses can capture? This quest for knowledge is inherently human and connects us all. Current telescopes and experiments are not just research tools, they are windows to the unknown. Each new finding, each hint about dark matter, brings us a little closer to the truth. Science is a journey, and each discovery is a stop along the way to a deeper understanding of the universe as we advance in the exploration of the Milky Way. It is crucial to remember that dark matter, although invisible, is fundamental to our galactic history. Without it, we would not be who we are. Isn't that a fascinating thought? So the next time you look at the starry sky, think about all that lies beyond the visible. The Milky Way is a place full of wonders, mysteries, and questions waiting to be answered. The search for dark matter is a reminder that, although we have come a long way, there is still a long road ahead. Each discovery is a step toward the truth, and every unanswered question is an invitation to keep exploring. The galaxy we inhabit is full of secrets, and it is up to us to unravel them. In the end, dark matter could be the key to understanding not only our galaxy but the entire universe. Who knows what other secrets lie hidden in the vastness of the cosmos waiting to be discovered? The Milky Way is a vast and enigmatic ocean of stars, but what happens when we look beyond its beauty? Behind every twinkle in the night sky lies a world of mysteries that invites us to question and explore. Why are there so many unknowns in our own galaxy? Throughout the centuries, astronomers have tried to unravel its secrets, and while we have managed to understand much, there is still a long way to go. One fascinating aspect is the way scientists attempt to understand dark matter. What is that invisible substance that seems to make up most of our galaxy? Despite not being able to see it, its influence is undeniable. The search for dark matter leads us to question the foundations of our knowledge about the universe. Could there be more than what we perceive with our senses? The answer is a mystery that persists, and its resolution could change our understanding of the cosmos. Additionally, there is the enigma of hypervelocity stars. These celestial bodies move at incredible speeds, as if trying to escape the gravitational pull of the Milky Way. What has given them that speed? Are they remnants of ancient destroyed stellar systems, or perhaps the result of interactions with other massive objects? Each discovery about these stars raises more questions than answers, prompting us to reflect on the chaotic nature of the universe. Fermi bubbles are another mystery that astonishes us. These gigantic energy structures emerge from the heart of our galaxy, but their origin remains unclear. Are they related to the activity of supermassive black holes? Or are they the result of cataclysmic events that have left their mark on space? Our curiosity about these bubbles drives us to investigate more about the dynamics of the Milky Way and its surroundings. Then we find the galactic voids, spaces where there should be stars but seem to have disappeared. Why are there regions in our galaxy that appear to be empty? Have they been devoured by unknown forces? Or are they the result of stellar evolution? The existence of these areas raises intriguing questions about the formation and destruction of stars, as well as about the very structure of the Milky Way. Another mystery that draws us in is the orphaned exoplanets, worlds that wander alone through the darkness of space. How did they end up so far from their stellar systems? Could they be refuges for life? Or are they simply echoes of a forgotten past? The exploration of these solitary planets invites us to reflect on the diversity of worlds that could exist in our galaxy and beyond. Globular clusters also generate great interest. These dense spheres of stars could be remnants of older galaxies. What secrets do they hold? Are they witnesses to the history of our galaxy? Each cluster is a time capsule, and their study can offer us clues about the formation of the Milky Way and its interactions with other galaxies over billions of years. The future of our galaxy is also filled with uncertainties. The inevitable collision with the Andromeda galaxy is an astonishing spectacle predicted to occur in about 4 billion years. What will happen to the stars and planets we know? Could new stars emerge from this titanic collision? Reflecting on our cosmic future reminds us of the fleeting nature of time and the grandeur of the forces that shape our universe. Cannibal stars which devour their companions are a chilling reminder that stellar life is not a peaceful path. What drives these stars to consume others? Is it the struggle for survival in a hostile environment? This phenomenon invites us to think about the life cycle of stars and how their interactions can lead to unexpected and violent outcomes. And we cannot forget the enigma of lost supernovae. It was expected that our galaxy would be filled with these bright explosions, but many have gone unnoticed. Where are they? Have we been looking in the wrong direction? This mystery reminds us that despite advances in astronomy, there is still much to discover and understand about the cataclysmic events that shape the Milky Way. Second-generation stars, born from the ashes of the first supernovae, also make us question the cycle of stellar life. How does the death of one star influence the birth of others? The relationship between creation and destruction in the cosmos is a fascinating topic that invites us to reflect on our own existence in the vast universe. The Sagittarius stream, which connects us to the history of a devoured galaxy, is another reminder that our Milky Way is not an isolated entity. What other secrets do stellar streams hold? Could they be clues about the past of our galaxy? Each of these invisible threads weaves a rich and complex narrative that challenges our understanding of the cosmos. The importance of continuing to explore the Milky Way cannot be underestimated. Each discovery, each mystery we unravel brings us one step closer to understanding our place in the universe. Reflecting on these curiosities not only helps us admire the beauty of the cosmos, but also reminds us that as we explore, there are always more questions to answer. What other secrets does the future hold for us? The adventure of discovery continues, and every glance at the sky is an invitation to keep investigating.